A fully furnished 10-story apartment building in China was completed in just 28 hours and 45 minutes. Not only the steel frame or outer shell, but the entire structure including walls, plumbing, electrical systems, windows, balconies, and interior spaces. Before most traditional construction projects even finish pouring concrete for a foundation, this building was already standing complete and ready for occupancy. Then the same company shocked the world again by constructing a 57-story skyscraper in only 19 days. Later, they pushed the limits even further by assembling a 26-story residential tower in just over 5 days. To understand how something like this became possible, you have to understand that the person behind it was not a famous architect or a lifelong builder. He was originally an air conditioning businessman named Zhang Yue. For decades, Zhang Yue built his fortune through Broad Group, one of China's largest manufacturers of central air conditioning systems. Construction was never part of his original plan. Everything changed after the devastating Sichuan earthquake in 2008. The disaster killed nearly 70,000 people and destroyed countless concrete buildings, schools, hospitals, and apartment complexes in less than a minute. The tragedy forced Zhang Yue to rethink the entire philosophy of modern construction. He realized that traditional concrete structures are extremely rigid. During massive earthquakes, rigid structures absorb enormous stress until they crack and collapse. Steel, on the other hand, can flex and absorb energy without breaking apart so easily. Instead of asking how to improve concrete buildings, he asked a more radical question. Why are we still building this way at all? That question became the beginning of a construction revolution. Instead of following traditional construction methods, Broad Group approached buildings the same way advanced manufacturing industries approach airplanes or automobiles. Every part of the structure would be designed and manufactured inside factories with precision engineering. Rather than constructing buildings piece by piece outdoors in unpredictable weather conditions, the company would create complete modular sections indoors under controlled conditions. The factory itself became one of the largest modular manufacturing facilities in the world, covering more than 230,000 square meters. Entire rooms were assembled there before reaching the construction site. Walls, electrical wiring, plumbing systems, air conditioning ducts, insulation, windows, and even interior finishes were installed before transportation. By the time modules left the factory, they were essentially finished living spaces. At the building site, cranes simply lifted the modules into position while workers locked them together using high-strength steel connections. There was almost no traditional construction taking place, no endless pouring of concrete, no waiting for materials to dry, no large piles of waste materials scattered across the site. The result was astonishing efficiency. Traditional construction projects are often delayed by weather, labor shortages, supply chain disruptions, and human error. Modular construction eliminates many of those variables because most of the difficult work is completed inside factories before assembly begins. The construction site becomes more like an assembly line than a chaotic building zone. This method dramatically improves quality control as well. In traditional projects, mistakes are often discovered after walls are already installed or concrete has hardened. In a factory environment, every module is inspected repeatedly before shipping. Measurements are standardized down to millimeter-level precision. Defects can be corrected immediately before installation. When Broad Group released footage of its 10-story apartment building being assembled in less than 29 hours, millions of people around the world watched in disbelief. Many assumed the footage was exaggerated or staged. Critics argued that such rapid construction could never be safe or durable enough for long-term use. Then Broad Group answered those doubts with something much larger. Mini Sky City, a 57-story skyscraper standing over 200 meters tall, was assembled in only 19 days. The building included office spaces, apartments, restaurants, and commercial facilities. More than 1,200 workers participated in the project, averaging nearly 3 floors of completed assembly every single day. What made the achievement even more impressive was the environmental impact. Traditional skyscrapers require enormous amounts of concrete, one of the world's most carbon-intensive building materials. Cement production alone accounts for nearly 8% of global carbon dioxide emissions, according to the International Energy Agency. Broad Group's modular approach reduced waste dramatically, while eliminating thousands of truck deliveries normally required for concrete transportation. The environmental advantages are becoming one of the strongest arguments for modular construction worldwide. Construction and building operations together are responsible for nearly 37% of global energy-related carbon emissions, according to the United Nations Environment Program. Governments are now under increasing pressure to reduce emissions from urban development while still building enough housing for growing populations. That pressure is creating enormous demand for faster and cleaner construction methods. The global housing shortage has already reached critical levels in many countries. The United Nations estimates that by 2030, around 3 billion people worldwide could require improved housing. Meanwhile, traditional construction continues to become slower and more expensive due to rising labor costs, material shortages, and complex regulations. Modular construction offers a possible solution because buildings can be produced at industrial scale much faster than conventional methods allow. Some estimates suggest modular projects can reduce construction timelines by 30% to 50%, while cutting material waste by up to 90%. But speed alone would mean nothing if the buildings were unsafe. This is where Broad Group surprised engineers the most. Independent structural testing in China found that the company's steel modular systems could withstand earthquakes up to magnitude 9. The buildings are designed with flexible steel structures that absorb seismic energy instead of cracking under stress like conventional concrete. Even more remarkable are the lifespan projections. Properly maintained modular steel structures may last hundreds of years, potentially far longer than many concrete buildings designed with 50 to 100-year lifespans. Because the buildings are assembled using bolted connections, many components can also be disassembled, upgraded, or recycled rather than demolished completely. While Broad Group focused on modular skyscrapers, another Chinese company called Winsun began experimenting with an entirely different idea: 3D printed houses. Instead of stacking prefabricated modules, giant robotic printers extruded layers of construction material one line at a time. Using mixtures of recycled construction waste, cement, and industrial materials, the company printed complete housing structures automatically. In one demonstration, Winsun reportedly printed 10 small houses within 24 hours. The technology drastically reduced labor requirements and allowed architects to create complex shapes that would normally be too expensive to build using traditional techniques. 3D printing also introduces incredible flexibility into architecture. Conventional buildings often rely on simple rectangular designs because curves and unusual shapes require expensive manual labor. With automated printing systems, complexity costs almost nothing extra because the machine simply follows digital instructions. This opens possibilities for affordable customized housing, disaster relief shelters, remote infrastructure projects, and rapid emergency construction. Around the world, countries are beginning to invest heavily in these technologies. Singapore has adopted modular systems for public housing developments. Japan and South Korea continue expanding factory-built residential projects. In Europe, modular construction is increasingly used for hotels, hospitals, and student housing. In the United States, companies are exploring factory-built apartment complexes to address severe housing shortages in major cities. According to market research from Fortune Business Insights, the global modular construction market is projected to exceed $170 billion within the next decade. Investors and governments see automation and prefabrication as essential solutions to rising urbanization and labor shortages. Still, despite all the progress, most of the world continues building the same way it did decades ago. The biggest obstacle is not technology. It is systems and regulations built around traditional construction methods. Building codes in many countries were designed specifically for concrete and brick structures. Approving new modular technologies often requires years of testing, legal review, and political approval. There are also economic and social concerns. Traditional construction employs millions of workers worldwide. Automation and modular systems reduce the amount of labor needed on site, raising fears about job losses across the construction industry. Entire supply chains, subcontractors, and equipment companies are deeply connected to existing building methods. Change on this scale never happens overnight, even when the technology already exists. But the economics are becoming impossible to ignore. Cities are growing faster than housing can be delivered. Construction costs continue climbing. Climate concerns are intensifying, Governments need faster infrastructure solutions, and developers need projects completed more efficiently. The direction of the industry is becoming increasingly clear. What began with one businessman questioning concrete after a devastating earthquake has evolved into a global transformation in how humans may build cities in the future. Factories replacing construction sites, automated systems replacing slow manual assembly, buildings produced with the efficiency of manufacturing instead of the uncertainty of traditional labor-intensive construction. For more than a century, people accepted that skyscrapers had to take years to complete. China demonstrated that under the right systems, they can rise in days instead. The future of construction is no longer theoretical. It already exists. The only remaining question is how quickly the rest of the world decides to catch up.